Good morning. Can you all hear me? Hello? Yeah?
Yes, sir.
Yeah. Okay. Anyone having problem logging on? Anyone having problem logging on? Yes or no? Right. Shall we start then? Do we have any questions on looking at this one tail, two tail table? I think last week I have given a quiz. Can you remember? Did I give a quiz to your group last week? No response. Did I give you any quiz last week? Yes or no?
Yes, sir.
Yeah. What is the answer? Yeah. So just I want to show you that I received your answers like this because I am just showing through the chat, the screen share, for example. Can you all see the screen? Yeah. For example, this is how the records are with me, right? So I will extract all the records about your answers. You see, for example, this particular person given the answer. Who is that? Let's look at. Oh, sorry. It is highlighted. Yeah. Like, for example, Subanki has given an answer like, you see, Subangi given the answer one tail, the answer is this, two tail answer is this, for example. That's all, nothing else is there. Maybe she might have sent again. So look at here, Bahiravani, Bahirav, what is that? Bairanavi, right? Okay, Bairanavi gave the answer as like this. So this is her answer. So I will extract all these answers. Don't worry, right? I can extract all these answers one by one. You see, we can receive all these information of the chat. So just to show you how we receive this information, right? So we can compile this, all the answers. It will record with your name. That is why I ask you all to always write your name or registration number. So it will record the chat with all this information. So I have already given the extraction to one of our staff members. So they will put it, the correct answer, wrong answer, then I will go through it. Right. Any questions? We have done a question last week, right? Have we? We have done an example last week. So basically, when you talk about one sample situation, right? When you talk about one sample situation, we can discuss a t-test, because this is the sampling distribution. Sampling distribution is along with the t-distribution, because it is dealing with a small number of samples, right? Since it is dealing with small number of samples, sampling distribution is dealing with t-distribution. So this t-test, basically, when we talk about t-test, we have two types of t-test. One is called as, we have already covered that, one sample t-test, that we have already covered last week, one sample t-test. The other t-test is called as two sample t-test. One sample and two sample t-test. So this is one sample t-test mean it is the same example that we have covered last week. It is coming from one population, one set of sample, one set of sample, right? When you say two sample, under the two sample, we have two different population. We have these two populations. One population is independent population. The other population is dependent population. Right? So population can be, if you have two population, these two population may be independent or these two population may be dependent. We will see that examples in few minutes. All right? So we have already talked about one sample last week. Now we are going to talk about two sample situation. Right? When you talk about two sample situation or two population situation, we can take, I will take independent sample population, right? I'm going to talk about two independent sample population. Right? I'm going to talk about two independent sample population. Any questions? Right. Now, when you talk about two independent sample population, we have two sets of sample. Right? We have two sets of sample. Suppose, let's say, these two samples, X1 and X2, two sets of sample, right? X1 sample, X2 sample. We can say these two samples are distributed normally. We assume that these two samples are distributed normally. For example, we can say X1 distributed normally with the mean of mu1 and with the variance sigma 1 square. So the parent population of the sample X1 is distributed normally with the mean of mu1 and the variance sigma 1 square. Similarly, the parent of the second sample X2 is also distributed normal with the mean of mu2 and with the variance sigma 2 square. We can write like this. The parent populations are like that. Can you remember the central limit theorem? So based on that, we can write the mean of these two samples. Can you remember the mean of these two samples, central limit theorem, is also distributed normally with the mean of same mu1 and with the variance of sigma 1 square divided by n. Right? Similarly, the mean of the second population is also normally distributed with the population mean of mu2 and sigma 2 square divided by n. Right? So here we say n and we can say n1 and n2. Sorry? Because the sample size may be differs, not the same sample size. Sample size may be different. So their parent population is this, which is also normal distribution, and the the mean of the population is normally distributed with the population mean of mu1 and their variance. Similarly, the x2 bar is also distributed normally with the mean of mu2 and the variance sigma 2 square divided by n2. Clear? So this is the basic assumption of the two independent samples. There are some other assumptions, we will talk about that a little later. Actually, what we are doing is, suppose we have a pool of information, right? We have pool of information. We extract one set of sample and second set of sample. Let's say this is the x1 bar, this is x2 bar. Actually, we are testing whether these are coming from the same population. We are going to test whether they are coming from same population. So this is what actually the independent sample testing is carried out. So basically, we have a pool of information. We have the mean of first sample. We have mean of second sample. We want to test whether these two samples, whether they are coming from the same population. If they are coming from the same population, no difference between those two. If they are coming from two different populations, there's a difference between these two. Right, let's say in terms of formulating hypothesis, right, null and the alternative hypothesis. When you formulate null and the alternative hypothesis, this is how we formulate the null and the alternative hypothesis. Mu1 equal mu2. Mu1 equal mu2. We know that is the mean of the first sample, population mean of the first sample or first population that we are going to test it. This is the mean of the second sample. Mu2 is the mean of the second sample or the second population that we are going to test. So basically we are seeing whether mu1 is equal to mu2. What is the alternative hypothesis then? Mu1 not equal to mu2. So this is a two-sided case. Again, here we can talk about one-sided and two-sided. So this is a two-sided, mu1, whether mu1 is equal to mu2 or mu1 not equal to mu2. So this we can write it as mu1 minus mu2 equals 0. That is also possible. We can write it like that. Mu1 minus mu2 equals 0. If you write your null hypothesis as such, then we can say the alternative should be mu1 minus mu2 not equal to 2. Right? So we'll have to write like this. Either we can write this set or this set. Both are referring the same thing. Okay? Both are referring the same thing, not difference. You can choose either this null and the alternative, or you can choose either this and null and the alternative hypothesis. Okay? Right. Now this is one aspect. Look at here. Another way of formulating your null and the alternative hypothesis. Null is always there as it is. What can you say about this one? Can somebody tell me what is the difference between this and this? Similar to our one sample case. What is the difference? Here we are talking about two-sided testing. Two-sided testing, because this is not equal to mu1 is not equal to mu2. So it can be either on the side. Here we are specifically, look at the alternative. Specifically we are saying mu1 is greater than mu2. What side are we talking about? We are talking about the right side. Right? Similarly, we can formulate another null and the alternative. We can formulate another null and the alternative. So here we talk about mu1 less than mu. We are talking about the left side testing. Left side testing. Okay, this is right side testing, left side testing. So here, whether it is a two-sided testing or right side testing or left side testing is again based on the question that we ask, the objective that we ask. So this formulation, whether it is two-sided or one-sided, is totally depend on how we ask the question. We will take an example. Let's look at it. Right? Any questions before we discuss an example? Yeah. Any questions before we look at an example? Before doing the example, we'll have to have some kind of assumptions, right? Anybody would like to ask questions? Anyone would like to ask any question? So here we are talking about two samples. We are going to test these two samples, whether the mean of these two samples are same or not. If it is not, whether mean of first sample is higher than the mean of second sample, or mean of first sample is less than the mean of the second. Yeah, anyone? Peony, yeah. Peony, yeah.
Sir, how it comes as mu1 minus mu2 is equal to 0?
Yeah, mu1. So look at this. So in a mathematics, look at this. Mu1 is equal mu2. If I write this as mu1 minus, if you take mu2 onto the left side, do you understand? Peony?
Okay, sir.
This is simple.
Yes, sir. Okay.
Right? Okay. So the difference is 0. So we want to detect whether the difference is 0 or not. Whether the difference between the sample 1 and sample 2 is 0 statistically. So that is what this is simple mathematics, right? So we say mu1 is equal mu2. So we can write it as mu1 minus mu2 equals 0. That is also true. So here, opposite to that, mu1 minus mu2 not equal to 0. If this is not equal to 0, or if it is equal to 0, we reject this. If it is not equal to 0, we accept this. Right? Okay? Right. Any questions? Right. Now, before we get an example, let's look at what are the assumptions that we carry out with two sample pool t-test. We call it as this two independent t-test, two sample independent t-test. Another name For that is 2 sample, 2 t-test. Right. So this is actually 2 sample independent t-test. Right. Let's look at some of the assumptions. When you carry out the test, we will have to have some kind of assumptions. The first assumption is samples are independent. Samples are independent. The first assumption is samples are independent. Okay? What do you mean by samples are independent? When you have samples, let's say this is indicating the sample 1. This is indicating sample 2. So we have values for sample 1 and sample 2 separately. Okay? We have set of sample, 2 different sample. When you say this independent, there are 2 independent aspects, right? Independency between these 2 sets of sample. So this set is totally independent from this. So we maintain the independency. We maintain the independency between these 2 samples. This is totally independent from this, or this is totally independent from this. Later on, we will see there are samples dependent. Now we will talk only independence. Right? Right. So the independency is there between 2 sets of samples. That is first thing. The second thing is the observation between or within one sample, the observations within one sample. So these are the observations within one particular sample. They are also independent. So the independency maintained within the sample. So 2 things in independence. We are maintaining the independency between 2 sets of samples, and we are maintaining independency within the sample also. Okay? All right? So independency between the sample and within the sample. Clear? Right. So that is the first assumption. Right? First assumption is that. The second assumption, as we already said, the distribution of parent distributions are normal. So that means x1 bar is distributed normally with the mean of mu1 and with the variance sigma 1 square divided by n1. Similarly, x2 bar distributed normally with the mean of mu2 and with the variance sigma 2 square divided by n. Okay, I will write the same thing here. Same thing here. X2 bar distributed normally with the mean of mu2 and with the variance of sigma 2 square divided by n2. Same thing I have written there. Okay. Third assumption is homogeneity of variance. Third assumption is homogeneity of variance. So what we try to say is, we are trying to say sigma 1 square is equal to sigma 2 square. So that is the assumptions that we are taking, the homogeneity of the variance. So the variance of the first sample and the second samples are equal. The variance of first sample and the second sample are equal. Okay? Variance of the first sample and the second samples are equal. So that is the third assumption. Okay? So these are the three assumptions. Later on we will see we can have the F test to test whether the variants are equal. We can see whether the variants are equal, or in other terms, we can test whether the variants are homogeneous or homogeneity in the variance. Why we are doing is that because if the variants are equal only, if the variants are equal only, we can have the procedure that we are going to discuss. If the variants are not equal, we cannot achieve through this, because the degrees of freedom will be differs if the variants are not equal. So we'll have to adjust the degrees of freedom. So there's a small differences in the test. Therefore, under these three conditions, only we can approach the test that we are going to learn now. So this is called as two sample t-test, two sample pooled t-test. So you can see here, this name is called as pooled, because why we call this as pooled is the variance that we are going to pool. The variance that we are going to pool. We will see what is pooling. Right? Is it clear? Right. Now I am going to do an example along with the formulas and so on. Any questions? Suhanya, Vidushika, DSKS Pereira. Any problems? Anything to be clarified before we take an example? Yeah. Are you all in? I spell out three names. None of them are replying. Are you all in or out? Yes?
Yes, sir. No, sir.
Yeah. So did you understand?
Yes, sir.
Yeah. Any questions? Anyone?
Sir, what is F?
I couldn't hear. Is that Suhanya? Somebody? Yeah, I couldn't hear your question.
Sir, what is F?
What is?
That F in that equation on the board.
This is F. Can you remember F distribution? This is called F distribution. I will do it a little later. F distribution. Can you remember F distribution? Did I talk about F distribution? We talked about chi-square distribution, T distribution. standard normal distribution. This is other distribution, F distribution. In your table, look at, you have a table book, right? 4, 5, 6 table are there. So one of the table explaining the F distribution. I will come to that, what it is, right? So we want to see like T distribution, T calculated value. This is given as F calculated value. F calculated value will be based on the ratio between these two variables. So we look at whether the calculated value of F is greater than the calculated, the table value of F. Then we take the decision, like the t-test. So here, this is the calculation based on F, right? We will do along with the example. Anything else? Good. Anything else? Yeah. Anything else? So I'm going to use a worked example. Otherwise, you will be in trouble calculating. Everybody will have different calculated value. So I will use a worked example, right? So I have two sets of sample. Let's say sample 1. Oh, I will say X1 and X2. These are the, let's say, average yield in metric ton of farmers from 2 villages. Let's say this is village 1, right? This is village 1, this is village 2. So these are the average yield per hectare, of farmers from 2 villages. I'm going to write down the values. You also can write down 120, 125, 115, 128, 130, 118, 120, 122, 120, 190. So can you tell me how many observations are there from village 1?
9.
Yeah?
10 observations.
Yeah. How many observations?
10 observations.
10. Right. Let's take another set of sample from village 2. For a particular crop, these are the yields of the farmers, right? Village 1, they received, first farmer from village 1 received 120 metric ton per hectare. The second farmer from the same village received 125 metric ton per hectare. Okay? So likewise, these are the information. Similarly, we can have the values for the second group of farmers which is coming from another village, not the same village, another village. Let's say village 2. The values are 118, 124, 114, 124, 125, 120, 121, 127, 118 and 121. Can you tell me what is the number of farmers taken as a samples from village 2? How many samples are there for village 2?
10.
10 again, 10 and 10. So here, please make a note. In this independent case, there is no need of having equal number of samples. So here we have 10, here also we have 10. So there is no necessity to have equal number of samples. But better to have an equal number of samples. Why? Because we can estimate the estimate parameters, mean and the variance with same precision if you have equal number of samples. So if you have equal number of samples, when you do the research, for example, you better to have equal number of samples. If you don't have equal number of samples, the samples which is having less number observation will have less precision in terms of estimating the parameter, like mean, standard deviation, no variance, and so on. Right? So when you do your final year research, you better to focus on having equal number of samples. But when there is no equal number of sample, still you can carry out the test. Right? Okay. Take a note of it. Right? So we have 10 number of samples for both villages. Right. Now we will ask the question. So this is the average yield of village 1 and village 2. Now we can formulate a question. What is the question that we are going to form? Right? We can ask the questions in different way. I'm going to show one way of asking. Test whether the average yield of farmers, test whether the average yield of farmers of village 1 is equal to village 2. So this is my question. Test whether the average yield of farmers of village 1 is equal to village 2. Is it clear, the question? I want to test whether the average yield of farmers from village 1 is equal to average yield of farmers from village 2. Is that question clear? Anyone couldn't understand the question? Vidushika, can you understand the question? Is the question understandable? Vidushika, are you around? Yeah. Is the question clear to you? All right. Somebody has sent Vidushika. No, somebody else. Right. Okay. So if the question is understood, now we will go through all these 4 steps. Can you remember what are those 4 steps? Tell me the 4 steps procedure in testing. Four-step procedure.
Formulation of hypothesis.
Yeah, that is first step. What is the second step?
Test statistics.
Yeah, test statistics. We do the calculation. We will come to that. That is second. What is the third?
Decision.
Decision making.
Decision making process. Fine. What is the fourth?
Conclusion.
Conclusion. Right. So all these 4 steps has to come one by one. So first step is hypothesis formulation. I will simply write as one, hypothesis formulation. So what is hypothesis formulation? So when you formulate hypothesis and the null hypothesis and the alternative hypothesis, you will look at the question. Right. Tell me what is your null hypothesis and the alternative hypothesis. So the null hypothesis, let's take village 1 population mean is mu1. Let's assume the population mean of village 1 is mu1. So I will say the population mean of village 1 is equal to the population mean of village 2. So that is my null hypothesis. Mean of the first village is equal to mean of the second village. Simple. What is the alternative? To find out the alternative, look at what is our objective. Our objective is to see whether the two means are equal or not. Yeah, go ahead. Yes?
Not equal.
Yes. Here, what we want to test is whether it is equal or not equal. So I will say mu1 not equal mu2. Now say I ask a question slightly different way, right? Test whether the average yield of farmers of village, so the rest is coming from there, right? Test whether the average yield of farmers from village 1 is higher than village 2. Is the question same here and here? Is the question same in both cases? No. Here the question is slightly different. Here it says whether you want to test whether they are equal. Here we want to say or test whether one particular village is higher than the another particular village. Village 1 average is higher than the village 2. So here what is null hypothesis? Null hypothesis doesn't change. What is the alternative hypothesis? Anyone? In this case.
mu1 is greater than mu2.
Yes, mu1 greater than mu2. We already said mu1 represent village 1. Mu2 represent village 2. So that we could write village 1 average yield is higher than village 2 average yield. So this is my null and the alternative. What type of test is that? Is it one tail or two tail?
One tail.
One tail, right tail. So you see that the alternative hypothesis, formulation of alternative hypothesis totally depend on how do we ask question. So if I ask, for example, in the exam, I'm going to do this one, but if I ask in the exam to do in this way, so your null and the alternative like this. If you write that, that is totally wrong. You will get marks for this, but this is wrong. If I ask this question, if you write this null and the alternative is wrong. So you will lose some marks here. You see? Clear? So you'll have to look at the sentence very carefully, whether I'm going to evaluate higher or lower. Sometimes we don't test whether higher or lower, like last time, whether this water can be irrigated. All right? So you'll have to think which side of test has to be performed. If the water can be irrigated in the one sample test which we learned last week. So thinking is important, and coming to a compromise is important, right? Clear? I'm going to erase this. You can write down very quickly of that alternative hypothesis where mu1 greater than mu2. Right. Now we'll proceed. So first step is over. What is the second step? Test statistics. So test statistics, the t calculated value for the two sample pool t test is given as x1 bar minus x2 bar minus hypothesis value divided by standard error of estimate. So the standard error of estimate is given as such. Write down that. So this is the formula. This is the formula. X1 bar minus X2 bar minus null hypothesis value. What is the null hypothesis value in this testing? Can you guess what is the null hypothesis value in this testing? We are testing whether there is a difference between mu1 and mu2. So, can you remember somebody already asked a question? Null hypothesis is mu1 minus mu2 equals 0. So, this is the hypothesis value that we are going to test it. Right? So, that is called as hypothesis value that we are going to test. So, is it necessary to have hypothesis value always 0? Testing hypothesis value, is it necessary to have a value 0? Yes or no?
No, sir.
No. So, now tell me, if I have a value 10, what are we testing now? mu1 minus mu2 is equal 10. That is what we are going to test. Tell me what do you mean by, what do you understand by this? So the hypothesis value, null hypothesis value, need not to be 0 all the time. You can test any values. You can test any value. For example, I have put 10, mu1 minus mu2 is equal 10. What do you mean by that? Think in this way. I have,
Average yield of
go ahead, please.
average yield of first village is larger than second village.
Average yield of
First village is larger than second one.
Yeah, that is true. Larger than second one, that is okay. But I have some value there, 10. I am going to test with this value 10. Look at this. Think about this example. Subject 1. So you have exam in subject 1, right? You have exam in subject 2. Two are independent subject. So I am taking sample 10 members marks. I am taking 10 members marks from subject 2. Now my null hypothesis is mu1. This is indicating mu1. This is indicating mu2. Right? Now tell me mu1 minus mu2 is equal 20. Think about it. Think about it. Marks, 2 subject. Think about it. Tell me. mu1 represent which subject? Subject 1. mu2 represent subject 2. Now tell me subject 1 average minus subject 2 average equal 20. Tell me what you are testing there. We want to see.
mu1 is greater than mu2.
Yeah, that is true.
Subject 1 average marks is 20 higher than 20% than mu2.
That is the important. Because mu1 is higher than mu2 that we can test, but we are looking at specific number. Suppose let's say subject 2 is statistics. Subject 1 is let's say biology. Subject 1 is biology, subject 2 is statistics. So what you are saying, on an average, the difference between these two subjects, that means subject one is subject one is biology. Yeah? Subject one is biology. Subject two is statistics. We can say on an average, biology marks minus statistics marks is equal to 20. That is what we are going to say, right? On the other hand, we want to test. On an average, students are taking 20 marks more for which subject? Biology subject than statistics. So that is what we are going to test. On an average, they are getting 20 marks more for biology subject compared to statistics subject, as an example. All right? Now, can you tell me our earlier example? mu1 minus mu2 is equal 10.
Village 1 got 10 metric ton yield higher than village 2.
Here, on an average,
So average.
on an average, the farmers in village 1 getting 10 metric ton more yield than the village 2. So that is what we are going to test it. You understand? So we can test any value as we like, right? So we can test any value as we like. So that is what I want to emphasize here. The null hypothesis value not necessary to have 0 all the time. We can test any value. It depends on the question. If I ask the question, test whether the farmers, right, having equal, these two farmer, village 1 average is higher than a particular value. That I can test. Oh, equal to a particular value, equal to 10. Right? So in that case, I can test it. So the hypothesis value needs not to be same all the time. Is it clear? Right. Now, you see this is clear. That is from the sample 1. This is mean from the sample 2. N1 is from sample 1, N2 is from sample 2. What is this SP? That SP square is called as pooled variance. So pooled variance. So this is why it's called as pooled t-test. So the pooled variance is given as S1 square into N1 minus 1 plus S2 square into N2 minus 1. Whole thing divided by N1 plus N2 minus 2. So this is a formula that you should remember, how to calculate the pool variance. Right, now what are the information that we need? We need for sample 1, we need the information about N1, X1 bar, S1, let's say S1 square is needed for the sample 1. Similarly, for sample 2, X2 bar, N2 and S2 square. So we'll have to calculate all these information for these two samples separately to carry out. Can you all calculate the sample size? 10 here, this is also 10. We have to calculate X1 bar, X2 bar, S1 square, S2 square. S1 square is the variance. We have to calculate the variance. Can you calculate now? I need to fill this blank, then only we can proceed with the question. Now we are in the calculation process, right? Because we'll have to substitute the values. N1 we know, N2 we know. But S1 square we don't know. We'll have to calculate from the sample 1. S2 square, that also we don't know, has to be calculated from sample 2, that is the variance. Then we'll have to calculate the x1 bar and x2 bar to complete this. Can you carry out and send me the answer to the chat or whatever it is? Yeah. So you can take a break also, 5 minutes break along with that. Huh? You can take 5 minutes break, then do it. Any questions? Right. Can you calculate? Because S1 square mean it is the variance of this. S2 square mean it is the variance of this sample. So you calculate the variance separately. Yeah, what is x1 bar? Some have written wrongly. What is x1 bar? Anyone?
121.7.
What about x2 bar?
121.2.
1.2. What about S1 square? Variance of
36.4.
Huh?
36.4.
194.1.
Variance. I'm talking about variance. Oh,
194.1.
oh something wrong with that. I think something wrong. 100 is wrong.
36.4, sir.
Yeah, 36.4 is possible. Not 36. I'm getting.
Sir, it is square or we want to square root. Take square root.
This is. I'm asking S1 square variance. You can take it. This is possible or this is possible. Either way is okay. This is variance, this is standard deviation. This is variance, this is standard deviation. If you take the square root of this, you will get this. So either of the answer is okay. Whatever it is, we can square it and get the value. Variance would be fine.
Then 13.93.
Which one?
S1.
Oh, I'm getting a different answer. Can you check it out?
36.4. Sir, S1 square 36.4. X2 square 35.4.
I'm getting a different answer. Try somebody else. We'll have to get the correct answer. We will find out S1 square and take these two values, S1 square and S2 square. Calculate these two. You have to calculate properly, otherwise you will be in trouble. I'm getting a different answer. That is why. That is why I came with some worked out answer, question. Otherwise, it will be a problem. Tell me what is the answer. Subhanya, what is the answer that you have sent?
21.56.
What is that? Answer for
S1.
what?
S1.
S1 square or S1? Don't.
S1.
S1 no. S1 square gives the same answer. You have.
No, S1 squared, sir.
Yeah. Square ko so I'm asking S1 square or S1. S1 means it is a standard deviation. So yes, S1 square is 21.56, something like that, right? So S1 square is 21.56. S1 square. What about S2 square? S1 square.
22.93.
20?
2.93.
22.93. Okay, 22.93. Oh, S2 square, right? I'm getting a different answer.
Yes, sir.
Hmm? Maybe somebody has sent me how the Vaishnavi. Vaishnavi, what is that?
15.28.
No, Vaishnavi has sent S2 square, right? S2 square is 15.28. S2 square is 15.28. Right? Now, no problem. We have all the information. We'll substitute on the equation. I will erase the whole setup. You keep this in mind, this formula. Only that information, summarized information is needed, right? Only those information is needed, right? Now still we are in the second phase of calculation. What is the calculation? First we'll have to find out SP square, right? But you see, we said SP square is S1 square into N1 minus 1 plus S2 square into N minus 1, sorry, N2 minus 1, whole thing divided by N1 plus N2 minus. Right. In simply, if the sample size N1 is equal to N2, let's say that is N. In this case, the sample size is 10. We have the same sample size, 10 each. If that is the condition, can you tell me the short form of this equation? Can you try and tell me what is the short form of equation? So we can substitute instead of N1, N, N2, N, N1, N, and N2, N. Substitute and see what is the answer that you are getting. Tell me, simple form, if the sample size are same.
2n minus 2.
Huh? What is that? Two n minus 2. No. I'm asking, substitute this with n. You see? Because n1 is equal n2 is equal n. So instead of n1, n2, we can substitute n. This is also n. This is also, sorry, this is also n. This is also n. This is also n. Now tell me what is the short form of this? Somebody?
Plus S2 squared over 2.
Once again?
S1 squared plus S2 squared over 2.
Divided by?
2.
Divided by 2. Right. Okay. So if the sample size are same, the pool variance is equal S1 square plus S2 square divided by 2 in simple form. The sample size are same. So we can apply the same thing, right? 21.56 plus 15.28 divided by 2. What is the answer? SP square. What is the answer? SP square. Anyone?
18.42.
18.4. All right. Right. Now I will erase this. You can substitute the values and get the values. We have a power failure. Can you all listen to me? Are you all listen to me? Can you all listen to me? Yes or no?
Yes, sir.
Yes.
Yeah, because I want to see whether we have disconnected. So we are connected still. So we have this information till the power comes. So can you calculate the rest? X1 bar is known. So we can say the T calculated value is based on what is our X1 bar. X1 bar is 121.7 minus 121.2. What is our hypothesis value? What is our hypothesis value? Anyone? Hypothesis value is 0. Hypothesis value is 0. Right? Whole thing divided by square root of SP square. SP square is 18.42 divided by 1 over 10 plus 1 over 10. Oh, I think that photo. Emily? Right. So fortunately, can you all hear me? Can you all hear me?
Yes, sir.
Yeah,
Yes.
because we have a power failure
Yes, sir.
in our room, so that is now the power comes and goes. Something wrong. But right, yeah. Somebody asked a question. Yes, go ahead. Somebody asked a question. Any questions? Yeah. Yeah. What was the question? Anyone? Can you all hear me? I want to get the response from you. I don't get the response.
We can hear.
You can hear, right, good. So here we have problems. Suddenly electricity comes and goes back. Something wrong with the system. Okay, What is the calculated value? What is the calculated value? Anyone? What is the calculated value?
0.260.
0.260 because I don't have the answer. I didn't calculate the value, so of course you could have calculated correct. Right. Now, how to look at the table value? How to look at the table value? Can somebody tell me? Take the T table. So this is the test statistics. Now we'll have to go for decision making process. The third step is decision making process. Right? Third step is decision making process. So what is the decision making process now? So we'll have to say, because it is a one tail or two tail. Null and the alternative hypothesis. Look at the alternative hypothesis. It is two tail. Right? We are talking about two tail situation. So this is the T distribution. This is a T critical value. One is plus, one is minus. So this is T critical value. Is T critical value, right? Okay. I will switch off the light and right. This is T critical value. Now we want to find out what is calculated value is already there. T calculated value, right? Now we'll have to find out the T critical value. How to find out T critical value? We need two things. One is alpha. Alpha is 0.05, no problem. What is degrees of freedom? We'll have to take the pool degrees of freedom. N1 plus N2 minus 2. So this is the degrees of freedom. So what is N1 plus N2 minus 2? What is that? 10 plus 10 minus 2.
18.
So that is 18. So the degrees of freedom is 18. Right? Degrees of freedom is 18. So this, take the table out. This table is given for two-tail situation. So in our case also it is a two-tail situation. So tell me what is the value of T?
$2.101.
2.101. 2.101. In other terms, the table value, I can say 2.101. So we can say if the calculated value, absolute value is greater than the table value, this is a two-tail situation, then we reject our null hypothesis. Can we reject our null hypothesis? Because the calculated value is 0.260, which is less than the table value. Which is less than the table value. So our conclusion, because you see here this is 0, the T distribution, this is 0, this is the value of minus 2 point, right? This value is minus 2.101. Here 2.101, it is a plus value, this table, right? Now look at our calculated value. Calculated value is 0.26. That is somewhere here. 0.26 is somewhere there. So what we can do is we do not. So this is non-rejecting area. This is non-rejecting area. This is a rejecting area. This is a rejecting area. This is non-rejecting area. So that we do not reject our null hypothesis. Do not reject H. Do not reject H1. So that is my decision making process. The last step, which is conclusion, right? Conclusion. The fourth step is conclusion. Fourth step is conclusion. What is the conclusion? Can you remember? Test whether the mean yield of village 1 is same as or equal to village 2. That is what our objective. Now what is our conclusion? We do not reject our null hypothesis. So what is our conclusion? Anyone? Do not reject our null hypothesis. What is the conclusion? What is the conclusion? Are you all still around? Can you hear me?
Yes, sir.
Right. Very quickly, because otherwise we will be lost. Maybe I will take another 5-10 minutes, then finish it off for the day. Tell me, what is the conclusion now? We are rejecting our null hypothesis. Sorry, we are not rejecting our null hypothesis. So what is our conclusion?
Average yield of farmers of village 1 is equal to village 2.
Yeah, because the average yield of farmers in village 1 is same as the average yield of farmers in village 2. So you can write down this. The average yield of farmers in village 1 is same as the average yield of farmers in village 2. Right? Average yield of farmers 1 is same as the average yield of farmers 2. Right? Average yield of farmers in village 1 is same as the average yield of farmers in village 2. So I think we will stop because of not enough clearness of the board here. Any questions based on this? Any questions based on this example? So the board is not clear, so that I don't want to continue. But you can ask any questions. I will spend some time to answer questions. Anyone? Anyone would like to answer? Oh, sorry, ask questions. Is it understand by everybody? Arshika, are you around? Sindhujan, Vaishnavi?
Yes, sir.
Yeah. Any questions?
No, sir.
Understood. Right. Okay. Varagunan, Jaturshi. I'm reading all the names appearing here. Pioni.
Yes, sir.
Yeah. Any questions? Because I'm not going to continue. I will stop here because not enough. Because we have other system where internet and others are working, but only the light is gone. So fortunately, internet is there. So don't know at what time it will also interrupt. So that is why I'm just. Any questions?
Sir,
Yeah.
in decision making, it is necessary to always show that calculated value is greater than the table value.
Yeah, normally that is the principle. That is the principle. So, I mean, you can show in this way. You can show in this way. Or otherwise you can show using this graph. Everybody understand? You mark the table value, then you see you mark the calculated value where it is falling, then you are rejecting. So if you show graphically, no problem. So decision making, you will have to have some kind of concept. We don't know whether you have copied from your neighbor or not. That we don't know, right? You understand? In the exam, you have to tell whether it is higher than table value or less than table value, or how does it comes. So that we should know. So that you can explain, right?
Then do we want to put that confidential interval or something?
Yeah, I want to continue with this, but no light. Is it okay if I continue, write down the confident interval? I can give you as a homework, because I want to continue with the same example. Because if we want to have confident interval, we will ask the question separately. If I ask you to test, if you ask to do the test whether this is equal to that, this is the procedure. If I ask you to construct the confident interval, then you will have to construct. So I will use the confident interval construction also here, right? So the second question, I can say construct (95% confident interval). I'll put it as, and test whether income average yield. Test whether average yield of village 1 is equal to the average yield of village 2. So I can ask the question likewise. So you'll have to bear with this light, right? So no light coming. See. Right. I just try to open the window because it's sliding windows. Right. So this is a question. Construct 95% confident interval and test whether these are equal. Right. So we can do it in that way. So I can put up the formula for confident. I have erased it. Right. Doesn't matter. What is the confident interval? So when you construct confident interval, let's say 95%. x1 bar minus x2 bar with the mean difference plus or minus, we take the table alpha by 2, the degrees of freedom is n1 plus n2 minus 2 into the standard error of estimate, that is the pool variance, into 1 over n1 plus 1 over n2. So this is the formula for confident interval. This is the formula for the confident interval. I think you can see that formula. This is nothing else. It is coming from the denominator of earlier setup, pool t-test. So this is x1 bar minus x2 bar. This is the table value, plus or minus, and so on. We can calculate this very quickly. In our example, 121.7 minus 121.2 plus or minus. What is the table value? I can remember. What is the table value? 2 point, the same table value.
2.101.
Yeah, 101. Okay, into square root of this value. SP square is 18 point something. Anyone? What is the value?
18.42.
42, right. Into 1 over 10 plus 1 over 10. Right? Can you tell me what is this value? What is that value? Tell me what is that value calculating? 0.5 plus or minus. Tell me the value of that.
1.191.
Right. So 0.5 plus or minus 1.191. So what is the lowest value? Lowest value is 0.5 minus 1.191. The upper value is 0.5 plus 1.191. So what is the range of value? This is minus 0.691 to plus value
Sir,
2 point 2 point
sir, 1.191 without multiplying by 2.101.
this one. We'll have to multiply that and give the answer. I said give the answer for this. What is the answer?
4.03.
4.03.
03.
Right. So this is like this. 0. Minus 4.03. Now tell me what are the answers. Tell me what is the answer. This is equal
3.532.
okay.
4.5.
What is the plus value? 4.5. Right. What does it mean? So this is my confident interval. So I can write few sentences. I am 95% confident. I am 95% confident that the true mean difference between village 1 and village 2 is in between true mean difference between village 1 and village 2 is in between minus 3.53 to 4.5. Right? So that is one thing. So we ask here to test using the confidence interval. We ask you to test using the confidence interval. So my null hypothesis and the alternative, as we said already, mu1 minus mu2 is equal 0. So mu1 is equal mu2. Same thing. Or mu1 minus mu2 not equal to 0. Or mu1 not equal to mu2. We can write either of this. So this is two-tailed situation. Look at this range of value. So here this is a rejecting region on both sides. Right? What is the lower limit? Minus 3.53. What is the upper limit? 4.53. So the upper limit is 4.53. The lower limit is minus 3.53. Now we want to test the mean difference of 0. Where does this 0 comes? Is it coming in non-rejecting region or rejecting region? Look at where this zero value comes? Where this zero value comes? Is it in rejecting region?
Non-rejecting.
Huh?
Non-rejecting.
Non-rejecting region. The zero value is coming in non-rejecting region, right? Therefore, we do not reject our null hypothesis, right? This zero value is falling in between this range. Look at this range. So this zero is falling in this range, right? So since zero, why zero? Because here zero is the one we are testing. Zero is falling. Zero is falling in the range. So do not reject our null hypothesis. Do not reject our null hypothesis. Or in other term, we accept the null hypothesis. Therefore, we can say the mean yield of village 1 is not different from the mean yield of village 2. So that means the mean yield of village 1 and village 2 are more or less equal. So that is my conclusion. You can make the conclusion. Same as earlier. Right? So here, as we already said, there is an advantage of confidence interval because we can test it and we can give this information also. So in the hypothesis testing earlier, what we have done, we cannot give this information. We cannot say the true mean difference is in between this value and that value. That can be set only using confidence interval. So that is the advantage of confidence interval. Right? That is the advantage of confidence interval. Any questions? Any questions? So we have constructed the confidence interval, right? So using the confidence interval, we can do the testing also. Any questions? Anyone? Jeffrey or Kamsatrani, are you around?
Yes, sir.
Yeah. What is the total number in your class? Is it 80 or 85 or 86?
85, sir.
85. Okay. Okay, but today I saw only around 70, 71 students join. I don't know the reason behind. Okay, right. Any questions? When you all are finishing your semester, is that the deadline given for this particular semester? Bachelor, any information about that?
Yes, sir. December.
Have you all got the information?
Yes, sir.
Till December, what date? Any idea? Till end of December. If it is end of December, I have enough time. No problem.
December 15.
Right. December 15 means we'll have to have 4 or 5 classes. Yeah. We need another 4 or 5 classes to complete it. At least 5 classes. So we will see whether it is possible. Right? Right. Okay. See you next week. See you next week then. Right. Okay. Bye.
December 5th, sir.
December 5th. So after that, what is the problem? Is there any procedure?
No, sir.
No. Then I'll have to have maybe I will see. Maybe in December I will have 1 or 2 class more in a week, so that I can finish it. Right? Okay then. See you next week. Okay. Bye.